All right, 3.6 part 2. So now that we've talked about our family of functions and our parent function, hopefully translations moving up, down, left, and right worked okay. Now we're going to do some reflections. Okay, so that's our next one, reflections here. So now we're going to do reflections. So reflections, really what they do is they flip the entire function over. So back in elementary, you probably would have called these flips. So it's going to completely flip the entire function over. Okay, so we have two different ways we can reflect. We can reflect over the x-axis. Again, the x-axis is that horizontal one. Okay, or we can reflect over the y-axis, which is that vertical axis. So let's go ahead and let's look at our parent function again. Okay, we go back to this parent all the time. So if we go back to the parent, oops, sorry. Okay, so there's our parent. If I want to reflect that over the x-axis, remember this is my x-axis here. So what that's going to do is it's going to take each of these points and it's going to flip it over that axis. It's going to move it down. So a reflection over that x-axis, okay, is going to take each of these points, so take this point here, and it's going to move it down. Instead of being up to, it's going to move it down to. It's going to flip it to down here. Okay, this point here will stay the same. This point down here now will need to still flip over that axis, so it's actually going to flip up here. Okay. So all of our points need to flip. So when we flip this guy over, we get this function right here. Okay. So really, to reflect over the x-axis, what it did is it took all my y-coordinates. Instead of this y being up to, it's now down to. So it took all my coordinates, my y-coordinates, and made them negative. So to flip over, I take my regular f of x, and to flip over the x-axis, I put a negative out in front of the whole function. Because we like to think of this guy kind of f of x here as almost our y. So it's taking that y and making it negative, or it's flipping over the entire function. It takes that function and makes it negative. So a negative out front of the function, so this negative out front will flip it over the x-axis. Okay, all right, so now y-axis, a y-axis reflection. Again, we start with our parent. Again, you can start with any parent. We just tend to start with the most basic parent. Okay, and now we're going to flip this guy over the y-axis. So my y-axis is right here. So it's going to take all of these points. It's going to take this point and it's going to flip it over here. Okay, this point will stay the same. I don't know, I'll take this point down here and it's going to flip it over here. Okay, so it takes each one of those points and it flips it over that axis. Okay, so if you notice, it makes that, here this x-coordinate was positive 2, now this x-coordinate's negative 2. So this puts the negative in on the x, so it'd be f of negative x to flip it. So if the negative is here on the inside, it's going to flip it over the y-axis. Okay, if the negative is here on the outside of the whole function, it's going to flip it over the x-axis. Okay, so here again, it says here we want to let f of x equal, they give us a parent, so first we need to graph that parent. Okay, so let's graph this parent right here, 1/2 x plus 1. Okay, knowing that there's my y-intercept, the y-intercept is at 1, and the slope is at 1/2, so this needs to cross the y-axis here at 1. Slope, rise of 1, run of 2, rise of 1, run of 2, rise of 1, run of 2. Okay, so there's my points. Connect my dots. Parent, right there. Probably should have done that one out a little farther. Okay, so there's my f of x. Okay, so now we want to graph g of x, which is negative. It's got that negative out front. So since that negative is outside, that tells me that's going to be an x-axis reflection. So I find my x-axis, which is right here, and I want to reflect each of these points down. So this point here, instead of being up 4, it's now going to be down, right here. This point here, instead of being up 2, it's now going to need to be down 2. This one, instead of being up 1, it needs to be down 1. Connect those dots. There is my y-axis reflection. It reflected this down. So this is my g of x function. Make sure you label it. Okay, next one is t. So we want to graph t of x equals f of negative x. So here this negative x is inside, so that's going to be a y-axis reflection. Again, we are reflecting f, that f function. So I take this red one. So now instead, my y-axis is here. So now instead, I'm going to reflect it over this y-axis. So this point here needs to reflect over here. So now it's over 1, 2, 3, 4, 5, 6. So I go this way. 1, 2, 3, 4, 5, 6. This point here is over 2, so this one needs to go back 2. This one here will stay there because that's what's reflecting, it's staying there. This one here is over this way too, so it needs to go this way too. Connecting those dots there. So there is again my y-axis reflection, so we'll label that as t of x. Okay, and then last it says 2. Describe the transformation from the graph of f. So to get to g, what do? F of x is reflected over the x-axis to get g of x. And then f of x is reflected over the y-axis to get t of x. Okay. All right, now I'd like you to do page 151. Ooh, what the world? Okay, we're missing some problems there. 151, problems 13 through, let me see, 13 through 16. So let's add a 16 to that. 13, page 151, 13 through 16.